For question number 1, we need to solve for x. And for this problem, we notice that we have fractions in the problem. And a very good strategy is to remove the fractions. And one way you can remove the fractions is multiplying every single term by the least common multiple. And when I talk about the least common multiple, we need to look at the denominators here, the 2 and the 3. And the least common multiple between the 2 and the 3 by inspection is going to be 6. Alright, so I can multiply every single term in this equation by 6. So I'm going to multiply the first term by 6, the second term by 6, and I also need to multiply this side by a 6. Okay, and then just do a little bit of math here. I have a 6 divided by 2, which is 3, and 3 times 1 is going to be 3. So I have a 3 over here, and then I have my brackets of x minus 1. Okay, and then I have a 6 over here, so 6 divided by 3, I always divide first. So 6 divided by 3 is 2, and 2 times 2 is going to be 4. So there's a negative 4 over here. And then I have an x plus 1. And then on the right hand side, I have 1 times 6, which is just 6. Now this equation is much easier to solve because the fractions have now been eliminated. So now we can distribute this. So 3 times x is going to be 3x. 3 times the negative 1 is going to be negative 3. And then if I have a negative 4 here, if I distribute the negative 4, a negative 4 times x is negative 4x. And negative 4 times the positive 1 is negative 4. And then on the right hand side, I have a 6 there. And then from here, we can collect like terms. 3x minus the 4x. Okay, so 3x minus 4x is going to be negative x. And then if I have a negative 3 and a negative 4, that gives me negative 7. And that equals to positive 6. Alright, after that we want to move the negative 7 over to the other side. So I have negative x over here. And if I add 7 to both sides, 6 plus 7 is going to be 13. And then I can divide both sides by the negative leading coefficient, negative 1. And my final answer here is going to be negative 13. Okay. Just for practice, I know this question doesn't ask for it, but just for practice, you should also try to just verify if your answer is indeed correct. So anytime you see an x here, you want to replace that with your answer, which is negative 13, right? So my first fraction, I have 1/2. Negative 13 minus 1 is going to be negative 14 minus 2/3. And then negative 13 plus 1 is going to be negative 12. And just check if that equals to a positive 1, right? So let's go ahead and do the math here. Negative 14 divided by 2 is going to be negative 7. Okay, and then negative 12 divided by negative 3 is going to be positive 4 times the 2 will be positive 8 equals to 1, and we do get 1 equals to 1. So just verify your work by putting your answer back into the original problem. Okay, so we want question number 2. For question number 2, I need to find the least common multiple and the greatest common factor for 18 and 24 using the tree diagram. Okay, so if I have 18, let's break down 18 into its prime factors using the tree diagram. So the two numbers that multiply 18 are 9 and 2. Since 2 is a prime, we can stop, and 9 we can break down into 3 and 3. So 18, if I write 18 into its prime factors, I look at all the prime numbers here, and I can write that as 2 times 3 times 3. Okay, and for 24, I want to break down 24 now using the tree diagram, and two numbers that multiply 24 are 6 and 4. 6 will be a 3 and 2, and 4 will be a 2 and 2. Okay, so if I have 24 now, if I write down the prime numbers here, I have a 3, a 2, a 2, and a 2. So let's go ahead and write out the prime factors here. So 2 times 2 times 2 times 3. Okay, now let's move to the GCF now, the greatest common factor between 18 and 24. Okay, so let's look at the common numbers here. So there's a common value of 2 right there. So let's go ahead and write a 2 over here, because they both share a 2, and they both share a 3 as well, right? So the GCF will be 2 times 3, which is going to be 6. So 6 is the biggest number that divides into 18 and 24. All right, so that's how you find the GCF. You find the common factors there. Okay, and then for the least common multiple, what we're going to do is we're going to try to match up the multiples here. So we notice that there's two threes there and only 1 2 there. So technically we need to add maybe we need to add 2 more multiples of 2 so that we have 2 on each side. So in total, we should have 3 2's now and 3 2's over there. So for our least common multiple, I need a 2, 2, and a 2. And then I notice here that there's 2 3's there and only 1 3 there. So I need to put another 3 here to make sure we match up with the 2 3's over there. All right, so we're making sure we're kind of matching up all the multiples here. And since we have a maximum number of 2 3's over here, and we have 2 3's over there, so we need to have 2 3's over here. Okay, so if I want to find my least common multiple, this would be 2 to the power 3 and 3 to the power 2. So 8 times 9 will be 72 as the least common multiple. All right, let's keep on moving on here. Question number 3, insert 2 numbers between 5 and 44, so the 4 numbers form an arithmetic sequence. Okay, so let's go ahead and just create a sequence here because there's only 4 terms. We know that the first term is going to be 5, and we know that the fourth term in the sequence is 44, and we need to find the 2 numbers that are between 5 and 44 to form an arithmetic sequence. Okay, from this, let's go ahead and analyze this. We know the first term is going to be 5. We also know that the total number of terms in this sequence is going to be 4, and we know the last term, which is term 4, we know that's going to be 44. All right, so once we have 3 pieces of information, we can actually jump ahead to our arithmetic sequence formula, which is Tn equals to T1 plus n minus 1 times the common difference. Okay, and we know that the n value here is going to be 4, so let's go ahead and insert the 4 for the value of n. And I don't know what the common difference is. And we know the first term is going to be a 5. Okay. And then let's keep on going here. We know that term 4 is going to be 44 equals to 5 plus 4 minus 1 is going to be 3, and 3 times the common difference. Okay. We can subtract 5 on both sides. So 44 minus 5 is going to be 39 equals to 3d. And then we can divide both sides by 3, divide both sides by 3. The 3's cancel, and d would be 13. Okay. If I go back to my sequence now, and now that I know my common difference is 13, we can just add 13 over here. So 5 plus 13 would give me 18. And if I add another 13 here, 18 plus 13 is going to be 31. And if I add 13 there, we do get 44. So that looks correct right there. That's an arithmetic sequence with a common difference of 13. Okay, the last review question for this homework for this particular homework assignment is that we have a system of linear functions, and we have a solution at the point -4, 4, and we need to write a system of linear equations that could represent this solution. Okay, so obviously there's multiple answers for this particular problem, but let's think about the easiest answer possible. And one way you can do that is by plotting the solution, which is at -4, 4. So this is where the solution is right there, -4, 4. And what we need to do is we need to create 2 linear lines that are going through that point. Now in class, I kind of mentioned one of the easier ways that you can solve this problem is just by looking for a slope of 1 from that intersection point. So if I have a slope of positive 1, we're going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and the pattern continues, and then we have another sequence over here. And then see if you can find the equation of this linear line right there. Well, for this linear line, I know the slope is equal to 1, and the y-intercept, which is the b value, is going to take a value of 8. So if I write the linear equation y equals to mx plus b, we know the slope here is going to be a 1, so 1x plus 8. All right, so that's the equation of that linear line. Okay, and then we go back to that intersection point, and we can now find a slope of -1. So just go the opposite way. Right, now I'm not going to draw every single point there, but I think the concept is clear. And then if I want to find the equation of that red line, we know the slope here is going to be -1, right? So this is a negative slope because the person is going down the hill. And we also know that the y-intercept is actually at the origin, which is 0, 0. So this equation is a little bit easier to solve. We have y equals to mx plus b. And we know the slope is going to be -1, so -x plus 0. Which is just going to be y equals to -x. Okay, so if I want to write out my final answer here, you would just kind of put the two systems of equations together, y equals to x plus 8 and y equals to negative x. So that right there is your system, your linear systems right there, and that is how you would write your solution for this particular problem. Okay, so that's the system equations right there. Moving on to the next question, we need to determine which of the following relations represented by graphs are functions. And the definition that we use for a function in this course is that for every one input, there is only one output. Okay, so another way that we kind of looked at this particular concept is by using the vertical line test. And if I look at this very first graph right here, if I draw a vertical line through this graph, we notice that the green vertical line intersects the graph at one point only, right? So what that means is for every x value, there is only one y value. So this is a function. However, if I look at my second graph here, if I draw a vertical line right through this part of the graph, you'll notice that we have two y values. Okay, so our current x value in this case, if I just kind of look at the graph here, it looks like my x value here is a 5, and if I write down 5, it turns out that 5 actually has, there's another y value here. Let's just assume this is 3, and this y value here is going to be negative 3. Okay, so if I look at the coordinates here, it turns out that we have two inputs, a 5 and a 5. We call that our input. And we have actually two different outputs, right? There's a 3 and a negative 3, right? So this actually fails our definition of a function, right? So the definition of the function is for every one input, there should only be one output. But it turns out that we have two different outputs here, right? So sure, this question right here fails the vertical line test, and a very quick way to determine whether we have a function or not is that if we have two x values, what that means is that we no longer have a function because we must have only one input. But if we have two inputs, then we have a problem there, right? So that does not fit our definition here. So this one here is not a function. All right, and we'll look for two x coordinates for future problems to fit our definition here. Moving on to the next question here. This one's pretty quick. If I draw a vertical line down here, there's two y values there, so this is not a function. All right, two different y values for a single x values. That's not a function. For this graph here, this kind of looks like a function here, right? So if I draw a vertical line through the graphs here, there are one x value and one y value for each of those vertical lines, so this is definitely a function. Okay, let's keep on moving along. Determine which of the following ordered pairs are functions. Now, we don't need to graph all this, but I'm looking at the x values. If I look at all the x values, it looks like all those x values are different, so that's good. Anytime we have two x values, that's when we don't have a function here, and this right here looks like a function. Moving on to the next one here, it looks like we have, this one is probably not going to be a function. All right, there's multiple x values, right? And if you had to kind of just sketch this, right, we have a point, here's the 2 value. Okay, so basically what's happening there's a point at 2, 2, 2, 3, and 2, 4. And if I just draw a vertical line right through those points, there's multiple y values there, right? So this is not a function here. Okay. Look on the next one here. Look at my x values here. Okay, so they're all different here, so this is definitely going to be a function. If I look at my x values over here, okay, so once again, we have the same x values there and the same x values there, so this is not a function. And I encourage you to just draw a sketch, and you'll notice that if you sketch these coordinates, you'll get a situation like this previous one here where it fails the vertical line test, all right? So I encourage you to just plot the points and make sure that you understand that the graph actually, the vertical line actually touches multiple y values, and that will not be a function there. Okay. So for question number 7, what I recommend doing for question number 7 here is we have this mapping diagram. I would actually start off by taking a little bit of time and writing out the actual coordinates for each of these diagrams there. And once you write out the coordinates, then you can easily determine whether it's a function or not. So let's just pause the video here and just take a few minutes here to write out the coordinates for each of the 4 mapping diagrams. Okay, so this is what you should have for your coordinates for each of the diagrams right here. And for all of these, for all 4 cases here, the only mapping diagram that has 2 x coordinates here is this third one down here. So this one's definitely not a function. And it turns out the rest are going to be functions here. So this is definitely going to be a function, this is a function, and this is also a function. And clearly all the x values are different. But it turns out in this third case here we have 2 x values, so that's not going to be a function. Okay, so this corresponds to our first definition way back here, right? If you have 2 x values, and if you have if you have two inputs, that's definitely not going to give you a function, right? That's going to fail the vertical line test. Okay, so moving on to the very last one here, determine which of the following relations represented by the table values are functions. Once again, just look at the x values here, and this one is not going to be a function because we have 2 x values there that are the same and 2 x values that are the same there, right? So this is not a function. Moving on to this one here, if I look at all the x values here, I notice that they are all different, so this is a function. And moving on to the next one here, 4, 2, 0, -2, -4, this is also going to be a function. All the x values are different. And on this last graph here, if I look at all the x values, they are all different, so this is also going to be a function as well. Okay, so that concludes this homework video guide, and that'll be it.